our least squares regression line. I'm going to tell you it's imperative that you pay attention and not be on your phones, not have your earbuds, AirPods, whatever you want to call them in. So what we're talking about here is one way to determine how well a linear model best fits the data set is by squaring the residuals. So the first blank that you're filling in is squaring the residuals. Okay? And examine the sum of the squared values. So you're going to square the residuals, and then we're going to calculate the sum of the residuals. Okay? Why do you think we would square the residuals? Anyone want to take a stab at it? Okay, to find an estimate of all of them. Good, good, good. Any other bright ideas as to why we're squaring? Okay, well, I'm going to tell you. What's going to be written here? I do not want you to write word from word. We're going to learn how to paraphrase. This is going to be fairly lengthy, but I'm going to read it, and I want you to write in your own word. That's part of learning. No, those are your notes. Okay, so squaring residuals ensures that all resulting values are positive. So basically, we're squaring to get rid of a negative. Does that make sense? That's because a negative times a negative makes a positive, okay? This ensures that our values aren't going to cancel each other out. Because if I have positive 2.5 and I add it to negative 2.5, what happens there? It's gone. It makes 0, right? So then, therefore, if they keep canceling each other out, am I going to have a good quality sum to add up to? No, I will not, okay? So that is why we are squaring the residuals. Now I want you to think back into geometry. In geometry, when you were squaring something, typically, what were you finding? The area of what? What shape? Triangle. It's part of the name. Square. A square. Oh my God. When you were squaring something, you were typically finding the area of a square. And that's what we're doing, okay? We're finding the area of a square. And so the smaller the area is, the closer to my line I am. Does that make sense? That means my residual is small enough that I'm almost on the actual value and expected value are almost the same. Okay? So when you are, what we're doing is we're finding the area of a little square that will get us closer. All right. Nope. Remember, we're not writing down everything that's up here. We're listening and paraphrasing. Okay? If you feel the need to write it all down, where can you locate these notes? Always there. Okay? All right. All right. So again, now we're going to start it. Okay? So we're going to do a little bit of practice. Are we ready to do practice? We're still using Stella, Jasmine, and Brandy. Okay? We're still using their data. They're still our friends. All right? Don't freak out. This slide is about to go away. You have been warned. All right. We're going to practice. So I need someone to tell me what were the residuals from Stella's information yesterday. What were her residuals? Negative 4.66, negative 2.94, 10.14, negative 2.42, 4.5, negative 5.86, right? Those were the residuals that we got from Stella. Yes? Okay, remember the residual is saying how far apart is your line from the actual point. Does that make sense? Okay, that's what we're looking at. Now, we're going to square the residuals. When I'm squaring a negative, is it necessary to put the negative in the calculator? No, because when you're squaring it, it's going to turn into a what? A positive, because a negative times a negative makes a positive. Yes. You were squaring them all. But I don't have to put the negative in, is what I'm telling you. So I put in 4.66 squared, and I get, we're going to round to the nearest hundreds. So this becomes 21.72. Because the 5 rounds the 1 to a 2. We're going to do the next one, 2 and 9400ths. Oh, didn't square it. 2 and 9400 squared, and I get 8.64. Okay. We're going to do 10 and 1400ths, 10 and 1400 squared. And what do we get? What is the 9 round the 1 to? 82. Okay, if you're not strong at rounding, you can go to mode. Everyone say mode with me. Mode, and see where it says float? You can switch to 2 and make the calculator do the rounding for you. If it's not your strong suit, the calculator can do that. Once you're done that, you're going to press second mode, and it's going to take you back to the page. And notice when I hit enter now, what did the calculator do for me? It rounded it for me. Do we see that? All right, so I'm going to continue. 2 and 42 squared gives me 5.86. 4.5 squared gives me, and it gives me 20.25. And 5.86 squared gives me 34.34. And then we're going to add them all up because it says the sum, and sum means to do what? Add them. I want you to add them and tell me what my sum is. I will go get him since it's raining. 193.25. What do we get? We hear some different answers. Okay, so here we go. 21 and 70. Oh, what thing go? So we have 21.72 plus 8 and 6400ths plus 102.82 plus 5 and 86 plus 20 and 25 plus 34 and 3400ths. Hit enter and I get 193 and 6300ths. You may have inputted a decimal wrong, Dustin. Okay, so the sum of my residuals is 193.63. Okay, the reason why the sum of the squared residuals is important is when you're comparing people's estimates, their expected equation, the person with the smallest sum is the one who is correct. Does that make sense? The person with the smallest sum is the person who's correct. So basically what we have here is a bunch of little squares. Okay, and we're finding all the area of those little squares. Okay, now what you're going to be working on is finding the residual squares of Jasmine and Brandy, and we're going to determine who had the smallest sum, which means that person was the correct one. Okay, they were the closest.
We get one of it on.
Yeah, I got it.
Okay, so it's 2 teams.
What's it be?
So you're finding
Yeah.
square sum,
I'm doing that.
and then you're going to determine who is the most correct. Jasmine, Brandy, or Stella. Brandy is such a weird name. Okay, take everything out of me now. Say Brandy. Brandy? Yeah. But I keep feeling like there should be a D in it.
I want to like. Maybe by everything. Not really.
And Martin, Martin. Right? I think she trying to put a we raise your hand.
We should document.
So when you found your expected.
Yeah, yeah,
plus
other branding,
and
we do,
right?
we can never talk.
If you get tested, but if you did it right, then that's what the need value.
I heard you got almost done.
So you plugged in your Y. Yes, remember, these are Y, we never input Y. We only input X, never input Y. Y is your. Y is right, this is why you're know it's practice or learning, right? Okay, your X is what you, your X. Okay. Don't do Y. I don't know. Any questions? So you say one, who had the smallest sum? Jasmine had the smallest sum, or your sum? But I don't Huh? You just gotta use the calculator or either Google the answer.
I think that.
All right,
Everybody.
you should be figuring out who was the right one.
Yeah, Chief Jasmine, Chief Jasmine.
Who had the smallest sum? The person with the smallest sum is the one who was correct.
Hey, Jasmine. Ryan, you won. Stella? Oh, it's Stella. Oh, right.
You never said Stella. You never said Stella, Nate, at all. When did you say Stella? All right, really quick. I'm gonna stop. So you're gonna continue to find the differences, calculate the residuals, and then figure out who has the smallest square sums, okay? That person with the smallest square sums is the person that was the most accurate with their expected equation, okay? Review questions asking you, what does the slope of the equation mean in this problem? So if we go back and look at our notes from yesterday, we identified what our x was and what our y was. So in this situation, our x was the amount of minutes that we drove, we had driven, and our y was the number of miles we had driven. So therefore, if I'm looking at the slope, slope is my change in my y over the change in my x. So that would be my miles over my minutes, which interprets to be miles per minute, is what my slope represents. Okay, what does the y-intercept mean? The y-intercept is your beginning value. So depending on which person you're looking at, your y-intercept is saying at 0 minutes, you were X amount of miles away from a starting point. Some miles, well, Y amount of miles from a starting point. All right, we will continue to practice this tomorrow. Have a great day.